all in one.
Oh, no.
It's going to be so much fun. Okay. First things first, let's go over what a reference angle is. Okay. A reference angle is an acute angle formed by the terminal side of the given angle and the x-axis. Acute angle formed by the terminal side of the given angle and the x-axis, okay? This is why we had draw this lovely bow tie shape, I call it, okay? If you're in this quadrant 1, this is your angle theta, okay? Your reference angles in this quadrant, are they not all acute in this quadrant? Mm-hmm. So that would be your reference angle. If you have a reference angle, if I say, what's the reference angle to 30 degrees? You would say 30 degrees. Say, what's the reference angle to 60? 60. To 45? 45. Because, so anything inside here, anything that's between 0 and 90 degrees is your reference angle. Okay? That is your reference angle. But if you land in this quadrant, okay, well, we have a problem now. And now I'm at 100 degrees, and that's not allowed. You can't, that's not your reference angle. Your reference angle can only be acute. 100 is not acute. So what do? Well, it's the angle that is formed with the x-axis. So I'm saying to you, how far are you away from the x-axis or 180? 80. You'd be 80 if I was 100. Okay, if I was 150, how far would you be? 30. So what you're actually doing is you're doing 180 degrees minus the theta, the angle. That's what you're doing to get the reference angle. Okay? If you're down here, the angle's down in here like 225. What would 225's reference angle be? Well, how far is it away from the... It's 45 degrees away from being at the x-axis. So what are you doing here? You're just doing theta minus 180. And then over here, you have angles like 300.
So be 60?
Right. How'd you get that? What'd you do to get that?
I just went to 360.
That's right. You do 360 minus the angle, okay? If you remember last year, I said to you guys, just you want to be closest. What's the closest angle to the x-axis? That's what you're looking at. You're looking, how close am I to the x-axis? So really, all you have to do is either subtract from 180 or subtract from 360, whichever one's closer, right? Isn't that the trick of it all? Either, look, subtract from 180, or subtract from 360. Unless you're a reference angle, unless you're already acute, then that's your angle. So let's just do a few of these real quick. Find reference angles. So 330, 240, we'll do a few degrees, negative 135, 565, 5 pi over 4, and negative 4 pi over 3. Okay, so find our reference angle. So think to yourself, 330, are you closer to 360 or are you closer to 180? 360 by how much?
30.
That's the reference angle.
Can you be negative?
You cannot be negative. A reference angle cannot be negative, not negative. And it's always between 0 and 90. These numbers should not be like 130. No, you're wrong. You're wrong. Okay. 240. 240, are you closer to 360 or closer to 180?
180.
By how much? 60 degrees. Okay. Ooh, negative 135. So there's a couple ways to do this depending on how you think about this. Okay, some people are like, well, they would find a coterminal. So they would add 360 and you would be at 225. And then although some of you are like, well, I know negative 135 would be right in here, right? And then how close am I to negative 180? Some people do it that way. But really what it is, it's 45 degrees. Again, everybody's different. I'm just trying to give you different examples. 225 is 45 away. Negative 135 is 45 to 180. So again, however you think about it. 565, again, you probably want to take away a 360 because you want to know where that is actually located. What is that? Is that 205?
Uh-huh.
Okay, 205 is definitely closer to 180 by how much?
25.
25. All right, now, radians. What do we do with that? So here's the trick with radians. I don't know if you remember it from last year. The trick is always this. See that right there? That's your reference angle, pi over 4. Do you remember what pi over 4 is in degrees? It's 45. Pi over 4 is 45. This is a 45. This is anything with pi over 4, 7 pi over 4, its reference angle is pi over 4, which is 45. 11 pi over 4, 45. It's always going to be pi over 4. Same thing with pi over 3. No matter if it's positive or negative, that we'll worry about in a minute. We'll worry about the negatives and positives because that tells you what quadrant you're in. But this, your reference angle is pi over 3. Okay? Anybody remember what pi over 3 is in radians? 60 degrees. Speaking of which, are you ready for the tricks?
Yeah.
I mean, where's Jack when I need to do my gang symbols? Square. Remember? You remember that last year? No? No one? Okay, great. I'm so glad I taught you so well. Yeah. Remember? This is cosine of this is 0, 30, 45. Yeah. So if I said cosine of 45, it would be square root of 2 over 2. This would be square root of 2 over 2.
I never wanted
Okay. Well, I am going to give you this chart, which I still like this chart. I still think this chart is helpful. If you don't like this chart, this is the chart that I think this chart helps me definitely for the tangent, especially because on the unit circle, you can't find tan. Well, I mean, again, you could divide, but you can't really find tan. I expanded this chart last year, so I have to remember it. So help me out here for a second. I think I went 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Ethan went all back. We don't want to talk bad. Love you, East Louie. Yes. In terms of radians, you might as well put radians on top. 30 degrees is pi over 6. 45 is pi over 4. 60 is pi over 3. 90 is pi over what?
Pi over 2.
Good job. I was waiting. 0, 0. Okay, now here's the trick that you do. Starting with 0, you go 0, 1, 2, 3, 4. You just start at 0 and count up to 4. Then the middle one, you start at 4 and count down. 4, 3, 2, 1, 0. Then do you remember this part? Put everything over 2, over 2, over 2. Do you remember doing this? Over 2, over 2, over 2, over 2, over 2, over 2, over 2. Oh, long cow. And then you take the square root of the top. Just the top. Square root of the top, square root of the top, square root of the top, square root of the top. Okay? Now, certain ones are special, like this one right here. What's the square root of 0 over 2 going to be, no matter what? 0. So this is just 0. Just put a big 0 there. That's always going to be a 0. So is this one over here. And then this one over here, well, even this one, square root of 1 is what?
1.
1. So this is really just 1/2. You can ignore. And the last one, square root of 4 is what?
Just 2.
And what's 2 divided by 2? 1. So this one would be 1. And then this would be 1/2. Okay, why is this helpful? This chart helps me because if I go, what's the sine of 30? You would say 1/2 without a calculator, because you have to do things without a calculator. If I said, what's the sine of pi over 3? Square root of 3 over 2. That's the ratio. What's the cosine of 90? Cosine 90 degrees, 0. Okay, very helpful.
Is that a pi, the first pi?
Pi over 6. Now, the tan comes from this, and this is really probably the part you have to memorize. Tan, you should all know, is your sine over your cosine. So if you take this top number and divide by this number, 0 divided by 1 is what? 0. The tan of 0 is 0. 1/2 divided by square root of 3 over 2 is actually, and I'll just give it to you, root 3 over 3. You get root 3 on the bottom, and then you just have to reciprocate. What's the square root of 2 over 2 divided by itself? 1. Tan of 45 is 1. Square root of 3 over 2 divided by 1/2, that's the square root of 3 only, just the square root of 3 on top. And then what's 1 divided by 0? Careful. Undefined. Okay, that's how you would do that bottom. So this chart is our best friend beside the unit circle. If you can't use a unit circle, which is what these questions are going to be right now. Do you all have this written down then? Just making sure. Now again, there were the gang symbols. I can't show you them right now. So I honestly cannot remember that trick to say. I think I do remember it. I think it's like, so this is 30 degrees. Sine of 30 degrees would be 1/2. This is your sine. This is your cosine. Cosine would be square root of 3. Weird. I know I'm weak on that area. I'm sorry. Okay, so I want you to sketch and find the exact values for all the trig functions. No calc, no unit circle. What?
So you want me to draw a unit circle?
You can if you draw the unit circle, then I would let you use it once you memorize it, which we will be given the opportunity next week. So I'll do 1 degree and I'll do 1 radian. Okay, and this is what they're going to say on homework tonight. Find all the trig functions, find the exact values to all the trig functions, no calculator. So how do we do this? So here's what I'm asking you for. This is really what I'm asking. Without a calculator, tell me what the sine of 315 is. Tell me what the cosine of 315 is. Tell me what the tan of 350. That's what I'm asking you for. Okay, and you're like, couldn't tell you. Can I use my calculator? No. But I'm saying, what's the sine of 315? What's the cosine of 315? What's the tan of 315? That's what all the trig functions are. And then we'll do it in the rest in a minute. Here's what you do. You first find your reference angle. 315's reference angle is what? 45, okay? So that means if you turn this back over, you reference back to this chart and go to the 45. All of your answers for sine and cosine and tan are going to be this, except for one little thing. So you see this right here? Square root of 2 over 2, square root of 2 over 2, 1. That's what I'm going to write right here. Square root 2 over 2, square root 2 over 2, 1. And then I'm going to reciprocate them. The reciprocal of sine is cosecant 315. That would be 2 over root 2. How do I rationalize that? What would that be, though?
Root 2.
Just root 2. Secant 315 would also be root 2. And cotangent 315, just what's the reciprocal of 1, y'all? 1. Now here's the only difference. I am not in quadrant 1. 315 is not in quadrant 1. I refer back to it because that's what all of them are going to be. But where am I located, everybody? Where's 315?
Cosine.
Over here. All students take calculus. In this fourth quadrant, only cosine and its reciprocal are positive. Just these two are positive. So then all I do is this. And I'm done. That's all you have. You don't need a calculator. I can prove it to you right now. I mean, you can hit tan. Am I in degree? No, of course I'm not. Tan of 315. -1. Okay, not 1. If you wrote tan of 45, it would have been 1, but you're in that quadrant. Does that make sense to you? Do you know how long we worked on that last year with y'all? You're like, I still don't get it. I know. Yay. It's going to be fun. Let's do it again. All right. So number 2, -5 pi over 6. So here's what I would do. I'd find my reference angle, which is pi over 6. I go to my little chart. Flippy, flippy. Pi over 6 is going to be all these numbers right here. 1/2, root 3 over 2, root 3 over 3. So I'm going to write it like this. Sine of -5 pi over 6 is what?
1/2.
1/2. Cosine of -5 pi over 6, root 3 over 2. Tan of -5 pi over 6 is root 3 over 3. And then you reciprocate them. Cosecant negative 5 pi over 6 is 2. Secant, what would that one be? What's 2 of
3 over
2 root 3 over 3? And cotangent is just root 3, right? Yeah. Okay, now, but the problem is some of these are negative because I have a negative 5 pi over 6. And I think this was another hard part that we did last year. Where is negative 5 pi over 6 located? How do you figure that out?
Well, if it was positive, it's not, it's less than 180, because it's not above the ratio of 5/6.
Yeah, that's how I think of it. Okay, this is what I do in my head. I know that this is 0. I know that this is pi, or even negative pi, right? Negative 1 is equivalent to 6 over 6, right? So negative 5 pi over 6 would have to come right before it going the clockwise way. So I'd be like, okay, I've got to go this way. Oh, so negative 5 pi over 6 has to go this way. Some people do this. Some people add 2 pi to it and find a coterminal. And if you add 12 pi over 6, you get 7 pi over 6, which is right here, same thing, okay? But you are in quadrant 3, and again, all students take calculus. What are the only 2 that should be positive up here? These 2. Put a little negative, a negative, a negative, a negative. That's what you have to remember to do tonight. Okay? How do you feel about that? It's been a while. That was very difficult last year. I remember everybody was like, no. And I'm like, I know. All right, let's move on, and then we're almost done. I only got these last 2 things, and then we'll look at my unit circle here. Using your calculator, which you will be allowed to for certain ones. So this is 3, part 4. Evaluate on the calculator. I believe this is for the last page. Secant of 17 degrees, cotangent of 19.2, cosine of 7 pi over 5, and cosecant 2 pi over 5. So I actually want you to get me the answer to what the calculator says. Here's the problem. Please know this about your lovely calculator. Your calculator right now in the top corner will tell you what mode you are in. And right now, if you look at my calculator is in what mode? Degree, okay? So I can do this problem because I'm in degrees. If I want to change to radian, I hit mode, and then I go to radian, which I will in a moment. Secant is not in your calculator, y'all. Secant is not inverse cosine. Secant is 1 over cosine, right? It's the reciprocal. So to do this one, you would have to type 1 over cosine of 17 degrees.
So you put the 1 over cosine in parentheses.
Yeah, you can. I think your calculator won't mind doing this one without parentheses. So 1 over cosine 17, 1.05, roughly. Same thing here. Cotangent is really what?
1 over 10.
1 over tan, 19.2. So what is it? What'd you get? 2.87, yes. Okay. If I now go to radians, which they're going to do on homework tonight, I now need to switch. So I now need to go into mode, down to where it says radian, hit enter, and your calculator should switch to radian at the top, or if you have the old ones, you just have to make sure, go back into it, I guess. Hit quit. Cosine of 7 pi, you must hit the pi symbol. You can't do 3.14. So you do 7 pi divided by 5, and I get negative 0.309.
So what's the difference between degree and radian? Like actually,
180 over pi and pi over 180. Okay. What would I do for this one right here?
1 over sine.
1 over sine of 2 pi over 5. And I have it equivalent to about 1.05. Okay. That will be very easy on homework tonight. Please just make sure you're switching from degree to radian, radian degree. So switch from degree to radian, and know your mode. That's where it's located in. It's in the mode function. Okay. All right. And last but not least, these are like the hardest ones. We're actually going to do more of these come Monday because I remember when I taught this year after year, everybody still struggles on this. Find two values, although my SPCC people had to do it for a homework quiz one night. To each function such that 0 is less than or equal to theta, which is less than or equal to 2 pi. No calculator. I love the no calculator.
Because you memorized it.
I wish I had.
The values what?
To each function such that, corresponding. I'm sorry. I just didn't want to write out the word corresponding. All right. So these will be like these are the last problems on your homework assignments page. I'm asking you to tell me what value of theta would get out a negative 1/2 when I find the sign of it, okay? So like sine of what? You're like, well, 45, sine of 45, that's root 2 over 2, y'all. Sine of 30, what's that one?
That's positive.
That's positive. I need negative. So here's, first things I want you to understand the following of what you're doing. To find an angle, you are actually doing the following. You're using inverse sine. Did you know that? Do you know that there's a derivative to inverse sine?
Wait, so this is what we haven't done
Would
before.
it be negative sine?
You've done this.
We've taken derivatives of
Oh, no, we haven't taken derivatives yet. No. But you've done this. You've done a problem like this last year. Yeah, in pre-cal. So this is, again, this is not negative sine. This is the inverse of sine of negative 1/2. What angle is that? Am I asking you for? Go ahead.
210.
Woo, nicely done, Andre. How do you do it? I know, I was like, okay, here's the best thing to do. Here's what I know. I know it's going to be 30 degrees. Again, how do you know it's going to be 30 degrees? Look right here. Look at your chart. The only thing that has a 1/2 is a 30-degree sign, correct? But it's positive. I need it to be negative. So what does that mean? Well, think about it with me over here. I know if it was positive 30, it'd be up here. That's where all students are. And over here, sine is positive here. That's 30 degrees. But I need it to be negative. So that means it's in quadrant 3 and 4, right? What are the 30 degrees in quadrant 3 and quadrant 4? What is the 30 degree here? 210. What did you do? 180 plus 30 is 210. So there's one. What's the 30-degree angle in quadrant 4? 330. Now, I do want you to find, again, notice what they used here. This right here is asking you to find it in radians. Again, once you memorize your unit circle again, you'll remember these in radian form. But this is, this is 6 pi over 6, so you're going one more, so 7 pi over 6. And this is 11 pi over 6. Those are your two angles that would, if you punch them in your calculator right now, sine 210, you would get out negative 1/2. Sine of 210 is negative 1/2. All right, let's do that again, because I know you're like, I got it, but I didn't. And you're gonna have to, that's why I'm saying on tonight's homework, please don't just assume you know how to do the problem and you're gonna use photo math. Really try it out. You gotta let that muscle inside of your brain try these out again. So cotangent, what's the reciprocal to cotangent? It's tan, right? If you reciprocate from this on this side, then why don't you just reciprocate this? That's how I do it. The reciprocal of negative square root of 3, let's say it's over 1, would be 1 over negative square root of 3, right? But then let's rationalize that. What would that be rationalized? Negative root 3 over 3. Okay, look at my chart. Let's go to my chart right here. Do you see a root 3 over 3 anywhere? Right where? Don't you see that right here? But I got negative again as a setup. That's okay. We know where negatives are supposed to be. Okay? For tan, again, all students take calculus. Tan is positive here and it's positive here. So I need it here and here because that's where it's negative. What are the 30 degrees in here and down here? What's the 30 degree up in there? 150. What's the 30 degree over in here? I think we just did it. 330. Okay?
How is 150 to 30?
I'm 30 degrees away from being 180.
Not 90.
Yeah. Okay, so 150 is the angle, and then 330 is the angle. In terms of radians, this would be, we're talking pi over 6. Anybody know what this one would be? This is 6 pi over 6, so we're just one away from it. 5 pi over 6. And this one I already found, 11 pi over 6. This is going to be your struggle. This is what we're probably going to do a whole day on Monday. So even if you still struggle at this, except for you. Why are you not an SBCC, you loser? All right, now, you ready to fill out your unit circle of fun?
Wait, I didn't get the.
Of course you did.
What is that supposed to mean?
I love you. Of course, yeah, I love you.
It's hard to listen and learn and write.
You're right. So many different ways that you all did it last year. That's why I kind of just let you go, and I said just memorize it however you want, okay? If you need help let me know if you can't read what these say.
120, is that root 3 over 2?
120 is 2 pi over 3, negative 1/2, root 3 over 2.